Chapter 9 introduces the first topic in our coverage of inferential statistics, and so that's confidence intervals. So now what we're going to do, instead of describing our data using a point estimate, which is the mean, we're going to use an interval instead. And so the confidence interval is a specific interval estimate of that parameter. It could be for the mean, it could be for the standard deviation, it could be for the variance. It estimates the population mean by saying, here's my point estimate, the sample mean, plus and minus some kind of error, that error that I'm going to allow to happen as I'm collecting the data. So what happens is, so in this equation that I've got in front of you, the margin of error of a confidence interval is that E that I'm going to add and subtract from my sample mean to create this interval that we're going to say the population mean is within. The margin of error is also called the maximum error of the estimate. Its formula is here up on the screen, the error. It's your z-score. So that's your z value that you're going to get. So we're going to call those our critical values, and we're going to look up those critical values depending on what percentage we're going to use for our confidence intervals. And then behind it in the big parentheses is sigma divided by the square root of the sample size. So the error is going to depend. So look, I've loaded it into this slide so that I've got that E. Instead of it saying E on this slide, I've got that formula in there. And so the error completely depends on the level of confidence that you pick. As the level of the confidence increases, the margin of errors increases. The sample size, as the sample size increases, the margin of error decreases, and the standard deviation of the population. Down below, I've got for a 90% confidence interval, our Z values, what we're going to use, those are called our critical values, and we're going to say that the Z critical values are 1.65. So the level of confidence is the middle percent of the standard normal distribution. So you're going to set that in the middle so that 90% is at the middle of the normal distribution with 5% in each tail. And so 1.65, in our book, we use 1.645, so we go to one more decimal place, and because of symmetry, that the z-score, this critical value, is plus and minus 1.65. If we've got a 95% confidence interval, we've got 2.5% in each tail, and our critical values are 1.96. For a 99% confidence interval, we only have 1% left, split in the two tails, and our critical values are 2.58. So here's an example. So here's the picture. So here's the 95% sitting in the middle of the standard normal curve with 2.5% in both sides. That's the idea that alpha is 5%. The confidence interval is 95%, 1 minus alpha. And so then what happens is that's what the distribution is going to look like with 95% in the center and our z-scores. So let's talk a little bit more. So that's kind of the basics. I wanted you to see the picture and kind of where you were going to go. So you can calculate the confidence interval by hand. And if you do it by hand, the first thing that you have to do is calculate that E. You've got to do your critical values times sigma divided by the square root of n and find that margin of error. And once you find that margin of error, you add and subtract it from your sample mean, and then you're going to be able to find that confidence interval. So in the notes I said, if your sample mean is 5.4 and I calculate my E to be 2.1, I'm going to take 5.4 and I'm going to subtract 2.1, and Then I'm going to take the 5.4 and I'm going to add that error, that 2.1, and I'm going to say my confidence interval is 3.3 to 7.5. So that's what we do if we did it by hand. If we're using our calculator, we're going to use Z interval. And so the Z interval command on our calculator, and then we can choose two different ways in the submenu to input our information. First way is we can choose data, and we can put all of our data into a list, and it'll do all our work for us, and it'll calculate the confidence interval from the list. Or we can choose stats as our submenu, and we can enter the sample statistics, the X bar, our sample mean, and our S. So some problems that you're going to find in MML are going to give you a list of data, and the others are going to give you a list of the sample statistics. So that's your introduction. That's what's going to happen in the beginning of Chapter 9. Then Section 9.2 continues on, and it talks about how to calculate a confidence interval when sigma is not known. And that's going to be using this T interval instead of Z interval. So T interval, if you're using your calculator, and I put up a little information thing on the T student distribution. That's the distribution that we're going to use to find the critical values for the section 9.2. So that's what's happening in 9.1 and 9.2, and then you'll continue on, and we're going to look at the idea of a proportion. And so that's going to use our calculator, and we're going to use one proportion Z interval. It says one prop Z interval, and it'll do all the work for us, and it'll give us the confidence interval back. So the calculator commands that you're going to use in this chapter are the Z interval, the T interval, and the one proportion Z interval. Okay, good luck. Let me know if you have any questions. Post anything on the discussion board, and let's have a good Chapter 9.